Hi, welcome to DFS Traversal. Depth first search can be used for directed graph and also undirected graph, which is given here, and also we can use for weighted graph and unweighted graph. So these two graphs are unweighted graphs. So unweighted graphs in the sense all the edges are equally having the weightage. So now in this DFS we will create the stack size with equal number of vertices given in the graph. For example, here we are having the here we are having the eight vertices, so we will create the stack with 0 to 8, 0 to 7. Okay, 8 number of locations. So now we can select any vertex as a starting vertex. So before that we will create adjacency list for each and every node in the given graph. So for A we are having adjacency vertex is B, so that is created here. For example, F we are having adjacency vertex is C. That adjacency vertex means nearby vertex which is having the outgoing edge from the source. So F is having the outgoing edge, only one edge to the C. For D we are having the three outgoing edges to E, C and F. So we are having C, F, E. So three vertices are there. After that we will select any vertex that is pushed into the stack. So we push through that G as a source vertex, push into the stack. Then we will, after that pushing, we have to check the adjacency vertices which are unvisited. So for the G we are having unvisited vertex is D and H. So we can select first one here, the D. So D is the first vertex in the adjacency list, so we will push that D into the stack. You look at that. So top of the stack is G. We are checking that, then we will repeat the step 3. So step 3 is we are push that non-adjacent non-visited adjacent vertices into the top of the stack. Then we will check the top of the stack element is D. So D is the top of the element stack. What is the adjacent vertex? So C is the adjacent vertex, then that will be pushed into the stack. Then top of the stack is C. The for that C we will check the adjacent vertex. Adjacent vertex for the C is nil. So if it is nil, then we will pop the vertex from the stack. So you look at that, if the no vertices are left for that node which is available on top of the stack, then we will go back means pop up the vertex. Okay, so from the C we will go back. Okay, from the C we will go back, right? So from the C, if you go back, pop up the element. After popping up, D is the element which is available. For D we have to check any other elements are unvisited. Yes, you look at that, F is unvisited, E is unvisited. So we can select from the adjacency list. F is the next node which is in the adjacent list. So F will be pushed into the stack. So after F is pushed into the stack, now we will check for the F there is any adjacent vertex which is not visited. For F there is no vertex which is not visited because C is already visited. So for F no visited unvisited stack, then we have to go back. For going back, pop the vertex, so F will be popped up. So like that we have to repeat for all the vertices which are until which are unvisited, right? Then until the stack will be empty. So now we will see the program on using Java. Here a graph is created with 8 vertices. So in this 8 vertices we will create the adjacency list. Okay, so for this 8 vertices we are calling the method main, so which is having the main is the class. Here it is having the linked list which is having the variable adj with array. So now we are having the boolean variable visited either true or false. So for this we are passing the 8 vertices. So for this 8 vertices we are creating the linked list. So initially for all the vertices we are having the empty adjacency list, and also we are having boolean variable visited for all the vertices. Now we are creating the adjacency list for 0th vertex. For the 0th vertex we are creating the adjacency list. So here for 0th vertex also we are creating. For first vertex also we are creating. For all the vertices we will creating the adjacency list. So here as of now we are having the empty adjacency list. So now then we are inserting the edge between 0 comma 1. So we are calling the method add edge, that is inserting the edge 0 comma 1. So we will create the edge between 0 to 1. So here we are having the adj of 0, like, so you look at that we are creating the adjacency vertex, okay, adjacency list based upon this insert edge. So adjacency list for adjacency of 0 adding to the destination 1. So now for the 0 we are having the 1 is adjacency vertex. So like that, next one is here the 0 comma 2 is there. So for the 0 comma 2 again we will create this. So for now 0 comma 2 is passed. So for this 0 add the destination is 2. So now we are having adjacency list, next node is 2, like that. Next one is 0 comma 3. So for the 0 comma 3 again here we are having 0 comma 3. So here the source vertex is 0 and add 3 is the adjacency vertex. So now we have added 3. So now for 0 we have created the adjacent nodes as 1 comma 2 comma 3. Actually it will be look like based upon the linked list, so it will be a head. So this is the next node and next node and next node. Okay, so this is the adjacency list for node 0, right? 0 is acting as a head. So like that we will create adjacency vertices by adding the edges one by one by the method insert edge. Okay, after that a graph is created based upon the inserting edges like this. Okay, so after creating the graph we are calling the depth first traversal. The starting vertex is here 3. So for the 3 we are calling the starting vertex. So 3 is passing here, then we are making that visited vertex is now true. Okay, so now visited is having the list, right? So 3 is visited. Okay, then we are pushing that into the stack by creating the stack variable yes. So push that 3 into the stack. So now 3 is pushed into the stack, right? Now we are checking s dot size not equal to 0. Yes, this is the stack. So stack is having one element, so it is true. So pop the yes. Okay, so now we are popping the 3, right? So now after popping the 3 that is assigned to variable x. So now look at that we are creating the iteration variable. So for adjacency list, adjacency vertex, you look at that for the adjacency vertex of 3. So what are the elements available? So here 3 is having 5 comma 6. Okay, so now 3 is having next 3 dot has next. Yes, it is true. If it is true, it dot next 3 dot next is here the 5. So 5 is the 3 dot next. Okay, so 5 will be assigned into n. So 5 is here not visited. Yes, it is true. If it is true, DFS is called now. So DFS is called now. Still this while loop is not getting over. Okay, still it is having one more element 6 also. So we have to wait. So now we have to wait for 6. Okay, so still it is in the track. Okay, so now the DFS is calling recursive call. Now the second track recursive call we are passing the 5 as the vertex. So 5 is visited now. So 5 is visited now. Then 5 is pushed into the stack. So now I am pushing that 5 into the stack here. So already 3 is over, but even though 3 is available in the track, okay, still it is this while loop is not over. Okay, so 5 is pushed into the stack. Then uh, here it is checking s dot size not equal to 0. Yes, it is 1. 1 not equal to 0 is true. Okay, so if it is true, getting inside the while loop, so now again it is checking for 5. 5 is having adjacency vertex 2. Okay, so for that now we are checking it has next. Yes, 5 is having next. So now what will be happen? I 5 dot next is 2. So this is it is the 5. So 5 dot next is the 2. So 2 will be assigned into the n. So now 2 is not visited. Yes, not visited. Now it is calling the DFS. Again we are calling the DFS for the node 2. Okay, for node 2. 2, right? So here for the node 2 we are making that as a visited, right? Still for the 2 for the 5 also, here for 5 also we are we have to keep on track. Okay, so now actually 3 is have visited, then 5, so still which is in the track. Okay, so now 2, so 2 is visited, yes, 2 is marked as a visited. The now that is pushed into the stack, pushed into the stack, so it is already popped up, 5 is popped up here, so it is deleted. So now uh, as of now 3 is pushed into the stack, so 3 is again popped up. Okay, so now for the uh, sorry, not 3, 2. Okay, so 2 is pushed into the stack. Okay, so here for 2 we are checking adjacency vertex, so yes, 2 is also having 4. Okay, so 4 is available, so here 2 dot next, so 2 is also in the track still. Okay, 2 is in the track, so now it is having the 4. Okay, so 4 is checking it, yeah, 4 will be visited or not, yes, it is not visited, so now we are making that into the DFS, so 4 is passing here. So now we will call this next time 4. Okay, so like this we will keep on do it. Okay, so for 4 again we are having the 7 comma 5. Okay, we will keep on do this. Then once this while loop is over, then this while loop will be again checked. So we will keep on go back, so go back is, I mean, tracking, so this 3 will be checked once again, and 5 will be checked, 2 will be checked, is it have any other adjacency vertices not, which are not visited, which are not visited based upon the algorithm. So finally it will give, you look at that, so we have the visited 3 5 2 4, you look at this, 3 5 2 4, next 4 is having the 7, you look at this, 4 is having the 7, so from the 7 there is no other vertices, then it has to go back. So at that time this while loop will be keep on come to check, right? So now, so finally 6, from 3 to 6, so after the 6 there is no path, it will stop the algorithm. Suppose if you take 6, you look at this, if you take the 6, 6 is the DFS we are calling, so 6 is calling here, 6 is made as a visited equal to 6, then push into the stack, 6 is pushed into the stack. Now we are checking, yes, s dot pop, so 6 is popped up. Now it has 6, so adjacency vertex of 6 list is iterator. So now we are checking 6, it has next, 6 not having the next, it is false. If it is false, okay, if it is false, this while loop will not execute. Okay, so this while loop will not execute, it will come out, right? When it is coming out, you look at that, already the 6 is popped up. So now s dot size is now 0, not equal to 0, which is actually 0 not equal to 0, which is false. Okay, which is false. So this while loop also now stopped, right? Once it is stopped, then algorithm will stopped, right? So now as for the 6, only the node is visited is 6. So this is the depth first traversal algorithm uh, based upon the stack data structure. Thanks for watching.